The idea that mass and energy are merely different manifestations of the same fundamental reality is a concept that challenges our conventional understanding. Albert Einstein's groundbreaking theories, particularly his prediction that we might never see the edge of the universe, have been a topic of extensive debate and fascination. Recently, the James Webb Space Telescope, JWST, has observed a peculiar void in the very early universe, which some interpret as potentially confirming Einstein's prediction. This raises profound questions. What exactly are we seeing, and is this void truly indicative of the universe's beginnings? To explore this, let's rewind to about a century ago when scientists first began looking beyond the Milky Way. Their initial observations revealed hazy nebulae, later identified as distant galaxies. The small and large Magellanic Clouds became visible, followed by the Andromeda Galaxy. Eventually, the realization dawned that the universe contained many more galaxies than previously imagined. This discovery led to the development of new ideas about the evolution of galaxies and the concept of an infinite universe. Edwin Hubble's observation that distant galaxies were moving away from us introduced the idea of an expanding universe. Shortly thereafter, the Belgian astronomer Georges Lemaitre proposed the Big Bang theory. These discoveries took place shortly after Einstein introduced his theories of relativity in the 1910s and 1920s. Despite the theoretical predictions made during this period being confirmed by new observations, Einstein remained uncertain about the universe's beginning and end. He fundamentally accepted the Big Bang theory but was skeptical about whether we could ever observe the universe's absolute beginning or end, regardless of how advanced our telescopes might become. Einstein's confidence in this prediction stemmed from two primary considerations. Firstly, the Big Bang theory and related theories postulate that for hundreds of thousands of years after the Big Bang, the universe was in a state of darkness, a period now known as the Dark Ages. During this epoch, there was no light available to observe, raising the question, how could we detect or observe an event or point in time from this period using telescopes if there was no light? Advancements in technology have provided some answers to this challenge. For instance, radio telescopes, which detect radio waves rather than visible light, offer an alternative way to study the early universe. However, researchers believe the Big Bang was not a loud event but occurred in silence. Space itself, which emerged with the Big Bang, was not conducive to sound. Radio telescopes detect waves that are beyond the audible spectrum, and space does not conduct sound well. Therefore, even if the Big Bang had been an explosive event, it would not have been audible. Cosmic background radiation, discovered in the 1960s, is considered an aftereffect of the Big Bang and has been extensively mapped. While this radiation provides strong evidence for the Big Bang, it does not directly lead us to the exact moment of the Big Bang. Einstein also proposed that the universe's expansion would cause its beginning to move further away, effectively putting it out of our observational reach. He even suggested that space might be curved, potentially hiding the starting point behind a cosmic horizon. In Einstein's time, the best telescopes could only resolve nearby galaxies. Today, our capabilities have advanced significantly, allowing us to observe millions of galaxies and peer back approximately 13.6 billion years, close to the time of the Big Bang. The James Webb Space Telescope, in particular, has made groundbreaking discoveries, revealing a plethora of extremely old galaxies that challenge our understanding of the Big Bang. However, the JWST has also detected a mysterious void in the very early universe, which might confirm Einstein's prediction regarding the limitations of our observational capabilities. This void, described as an absolute void, poses a significant puzzle. These voids are regions of space so empty that they seem to contradict some principles of relativity. However, they might also support Einstein's notion that the absolute beginning of the universe is not observable. Initially, this void was thought to be an indication of the Dark Ages, a period with few stars and galaxies. Researchers believe this discovery confirmed the existence of this epoch. But further analysis revealed that this darkness represented an extremely distant void rather than just the early universe's lack of light. Closer and more recent voids have already presented challenges, but an extremely early universe void poses even greater scientific dilemmas. These voids do not fit well with the idea of a homogeneous universe, which is a key component of the Big Bang theory and the concept of expansion. They are too large and too strange, exhibiting an inhomogeneous character that conflicts with our cosmological models. The JWST findings so far have not revealed any direct evidence of the universe's absolute beginning or an early stage. Instead, the images show structures and galaxies that are not significantly different from those observed in more recent parts of the universe. This raises the question of whether a mysterious void could have been the origin of the universe. While it is impossible to entirely rule out this possibility, we must acknowledge that our understanding of voids remains incomplete. We do not know what these voids truly represent or if they contain unknown forms of matter. Some theories propose that voids might be dark galaxies or even parallel worlds, while others suggest they could be remnants of collisions between universes in a multiverse scenario. More speculative ideas include the notion that advanced civilizations might manipulate voids to harvest energy. The mystery of voids challenges our scientific models and has led to a range of theories from plausible to fantastical. One intriguing possibility is that our universe might have originated from a large void. This concept remains speculative, as the inability to prove otherwise reinforces the idea that the universe could have emerged from nothing. The question of how matter emerged from this state of nothingness remains one of science's greatest mysteries. A singularity is a point where all known forces are so concentrated that conventional dimensions and values break down, or where everything that exists is compressed into a single point. This point of singularity is thought to have originated from a state of complete equilibrium, disturbed by an unknown event that triggered the creation of the universe. From this infinitesimally small point, everything we know and observe today emerged. This means that all life, every star, and every exoplanet were contained within this tiny dot of nothing. Understanding how such a minuscule point could encompass everything is a profound mystery. In a stunning revelation, the James Webb Space Telescope has uncovered a surprising emptiness in the early universe that might just validate one of Albert Einstein's most intriguing predictions. Today, we're exploring how this remarkable discovery could prove Einstein was right about the limits of our cosmic vision. Albert Einstein, renowned for his theories of relativity, made a bold prediction about the edge of the universe. He suggested that no matter how advanced our technology, we might never truly observe the universe's absolute beginning or its outermost edges. But what inspired this idea, and why does it matter now? In the early 20th century, scientists began looking beyond our Milky Way and stumbled upon the vastness of the universe. They discovered not just new stars but entire galaxies, leading to the groundbreaking realization that the universe is expanding. Edwin Hubble's observations of galaxies moving away from us laid the foundation for the Big Bang theory proposed by Georges Lemaitre. Einstein, initially skeptical of a dynamic universe, eventually accepted the Big Bang theory. However, he remained doubtful about our ability to observe the universe's absolute beginning. He believed that as the universe expanded, the point of origin would keep moving away from us, making it perpetually out of our reach. Fast forward to today, and we have the James Webb Space Telescope, our most advanced tool for exploring the cosmos. Webb has detected an astonishing void in the early universe, an enormous, seemingly empty space that challenges our current cosmological models. This void, found in what is believed to be the universe's infancy, is so vast